Hi, my name is Ali Reza Berrimond, and this is my SER456 Final Semester Project. Now, this isn't how it's supposed to look in its final state, meaning I do want to set this project up in my backyard. However, by doing so, I will be making some alterations to the wiring, and just in case that causes any issues, I want to have a video that shows it in its final state before I actually put it into use at my house. So first up, we have the soil moisture sensors. These sensors detect the water moisture level inside of the soil and tell me if it's dry or moist. I have it placed inside of a cup of water to simulate it being inside a pot of soil. These give me analog signal outputs, therefore they're hooked up to the port D pins on my Atmega 168. Next up, we have the TSL2561 Lux sensor. This uses two channels to determine both infrared light that is invisible to the human eye and then a simulated measurement of light visible to the human eye. It then uses some sort of formula that's given inside of the datasheet to convert both those inputs into a lux calculated unit. This determines how much sunlight is inside my environment, and I use this to distinguish whether it's cloudy outside or sunny. Right now I'm shining a bright light on it to simulate light so I can get some readings. And this, too, is hooked up to the I2C pins for the S data and S clock on my Atmega 168. The register address is different than that of the ADXL345 and the other I2C sensor that we'll be showing next. Buried within the wires there, we have the ADXL345 accelerometer. Using those two holes we see there, I'm going to tie a string through them and then pin it against the wall. From there, I'll use the x-axis to simulate wind measurement. Basically, if the accelerometer moves past a certain thresh within a certain amount of time, then I know that it's windy outside. Therefore, this will be my wind sensor, and this is hooked up to the I2C pins on my Atmega. Next up, we have the HTU21D temperature and humidity sensor. This operates in a similar fashion as the Lux, where it uses two input channels, but both these input channels go against another equation given through the datasheet that outputs the temperature reading in Fahrenheit or Celsius, along with the humidity of the environment. This as well is hooked up onto the I2C pins of my Atmega and uses a different address that separates it amongst the ADXL and the TSL2561. This will be placed outside as well to detect the temperature of the backyard. Lastly, we have my laser detector sensor. Now this just provides me digital output, a 0 or a 1. A 0 means that this laser within that little gold cylinder there has no obstacles blocking its line of sight. It knows this because above it, it has a little light detector, and that light detector detects the beam bouncing back from the laser. If it doesn't see the laser, then it knows that something's blocking it. This gives me a signal through my port B, pin B0 of my port B on the app.
So we're going to SSH into the Raspberry Pi, which I've gone ahead and already done. And then from there, I'm going to go ahead and run the Apache server. The code to do so is actually on Apache's website. So now we have the localhost server running on the Raspberry Pi. What we're going to do next is go into the directory where I have the C code to read the sensor values. This is using the AVRDude library. This will then send the sensor values using serial communication to the Raspberry Pi that I'm currently SSH'd into. So let's go ahead and do that. So we have all my project files here. I'm going to go ahead and upload the code to the USB Tiny ISP. Awesome. So now we're going to go back to the desktop. In the desktop, we have the web page generator Python file. This will be run using Python 2, and what this does is it parses the serial communication and then extracts the necessary data and creates a web page out of it that I will go ahead and navigate to on the Chrome window behind me. So let's go ahead and run that Python 2 file. So it goes ahead and outputs the serial communication we received from the Atmega onto the Raspberry Pi. And we'll go ahead and extract all this data within that file and render it on a web page. So the web page will be on the Raspberry Pi's IP address, and the HTML file it creates will be called sensor readings. This file is stored on a relative path with respect to the Apache server. The path you put this file in is given on Apache's website, where you'll find the information on how to construct this. Nonetheless, let's load the web page and make sure the values match. So it looks like we have a pretty nice looking backyard currently. Nothing too shabby, But let's make sure the temperature and all these values match. So we see we have 78 here on the web page. If we go back to the terminal window, we do have indeed 78 degrees Fahrenheit. And it looks like our humidity and all other values are matching. Now, the lux value is calculated using the two luminosity channels. A ratio is given, and then from there, an equation is done. But nonetheless, this gives us the web page.